Let's see if we can last
Last hour we had Mr. West.
Yeah.
And then I know a bunch of teachers are gone because of is Carlene gone?
No.
But she was talking about like turning in all the stuff on Friday.
Hey, there's
Like,
Vanessa.
don't we
Good
have
morning.
Thursday?
You guys don't have any more German class.
We have it on Friday.
No,
No,
like
just-
Friday and then if we don't have.
We don't have it
Well,
Thursday?
we could go. No, we've never had.
Huh.
Oh, yeah.
Okay, I think we're getting it mixed up with sport, which is like Wednesday, Thursday, Friday. Thanks.
And there's Isaiah. Good
I
morning,
think I just pulled
Isaiah.
a dum dum, but it's okay. Yay, positive. I'm just, wait, what? Negative. Let's go.
You're positive it's negative.
Oh, wow.
All right, let's see if we get some others there.
Oh,
I'm not here tomorrow, so.
no.
I don't know.
We just showed this a face of disgust. You're getting vaccinated?
Nice.
I'm getting vaccinated during the summer. You know, in America, once you're vaccinated, you don't have to wear a mask.
How we didn't know.
Still kind of screwed. Do they have vaccination cards?
They have vaccination cards. It's gonna be like a nightclub instead of having to like, YOLO, yeah, just show your vaccination card.
Vaccination card.
But it'd be funny because the only people in the club would be old people. Just imagine that.
Yeah, you don't go to
Oh,
like
yeah.
restaurants.
Do you guys already have a line that's pretty cool?
Yeah.
You, the same applies if you just got a negative
Okay,
test.
so this is,
Yeah, but the vaccine is like a negative test every day.
Wait, what?
Like every week, every year, every decade, every century, every millennium. Because they're gonna download my brain onto a computer. Oh, I can't wait till they download my brain onto my computer.
Yeah, so if
Wow, it's so cool.
That's how it is.
But it's, you know what, biological,
Now we have a lot
biologically,
of
you're
younger
like,
Germans are very angry now because like there was this thing was like after this facility getting changed, but now they're like, oh, what facility getting changed yet? Now all the old people will go outside and grab the last of the room, you know. And I heard some of it.
when we go to school and we're the ones who like need to go places. Whereas they give the vaccine to people who didn't want to go places.
Right, I feel uncomfortable with that.
Yeah, also-
Vaccinated.
I feel indifferent.
That's what
I'd rather be
no one asked you.
vaccinated.
No one asked you.
You're not part of this conversation ever.
Okay.
Yeah.
And it's all my mom. So my mom doesn't even live here.
Yeah.
So sad. I'm sorry. Oh, wow.
okay, let's see if I got some others. I got Alessandra as well. Good.
Where's John?
I forgot to send an invite out, so I hope they actually show up anyway, but
Oh, yeah.
You know?
Posting something on Slack.
I could just tell them on WhatsApp,
Yeah,
just
we
say.
could send something.
if someone could send them to the class chat, that would be
I'll send
great.
one right now. I'll just say
Because,
chemistry now.
I just want to say it's every chem class until further notice, so, sorry, physics class until further notice. Okay,
Oh, nice. Okay. That's what I like.
thanks somebody for doing that. Once you're negative, just raise your hand so I can go ahead and. You still waiting?
But it's, I don't get the whole 15 minutes. I guess just a hard confirm, but right
Okay,
now.
so, folks at home, we are, I got you, Isaiah. Thank you. Don't worry. Folks at home, we're testing for Corona, so I'm gonna set up the demo for today while they're doing that. Okay. Folks here, did we start the 4 stations? Did I give you that sheet and we began not at all? Ooh, Did we talk about the Lorentz force and the comparison between generator and, good, okay, so we have some work to do today. Wow, all right, so. Folks at home, I think I sent you this. Let me take a look. So, we got Isaiah, Inessa, Alexandra. I think I sent you this sheet. Let's just find out.
Oh, you know who probably isn't there? Probably Jack. Is Jack? I don't think Jack would be there.
Oh,
Nice.
we could close that, open that.
What's a perfect way to wake you up in the morning when the wind blows the door shut at insane speeds?
I know that earlier, but, okay. I got something wrong.
So someone's word gets spoken.
Electromagnetic effects, yeah, okay, so, folks at home, you have this, okay, you have it, Alexandra, you're way ahead of me. I sent you the sheet already on electromagnetic effects. I'm gonna give it to my folks here. And actually, you know what? Could I ask you, Aslan, to just give everybody one? Okay, that'd be great. While you do that, I'll get it. I'm sorry, how you doing? Okay, how am I gonna do this today? Thank you so much, I appreciate it.
I actually did some work that I didn't hear that. Well, I wanted to read it for fast, I do have to do that.
Okay, so there's that, and there's that, and there's that. Okay, so let's get all this stuff away. Holy moly, you know, it's a wonder we get any teaching done at all. I got so much to do. Live stream, demos, crazy amount of equipment, stuff, junk, cherries. Gosh almighty. Be glad when the school year's over, I can't tell you.
I mean, negative. I would say everyone has this positive, yeah. But then forget, negative is the good one.
Okay. And once you get your negative, just come on up and show me, and then I will wave happily, and you can sit down and throw your negative thing away in the gray bucket. In the meantime, let's take a look at this. We're going to do station 1 to start off with. These are 4 different demonstrations with electromagnetic effects. I'm going to try and do it so folks at home can see these as well. So the first thing, we need what? What do I need to get off my cart? I need to, I got to get a bag, a big one, right? So there's that. Whoa, okay. I'll put that here. Folks at home, I'm going to make it so you can see that. Okay, you got a big magnet. Good. What else? What else can we describe there? Isabella? A copper coil. And it's going to be one with a whole lot of loops. And I'm going to use, I think, this one here. And notice I need a hoop attached to it. What is that in the diagram? What has to be attached to my loops? Little symbol there. Something's got to be attached to it. Yeah? Yeah, I got to have a lead, but then it's attached to something else. What's on that lead somewhere? what, Aslan?
Voltmeter?
Voltmeter. See that V at the top? So we're gonna put a voltmeter attached to this sucker. And I've got so many. I don't know quite what I've done here. I think I did this one. There it is. Okay, so here we go, folks. Oh, that's disturbing. That's not what I want at all. All right, here we go again. I guess. Okay, so I got a coil, and the coil is connected with a couple of leads. Man, it looks complicated, but it's not. One lead going in, one lead going out of this voltmeter. Good. And now I'm going to put the voltmeter here, and I'm going to do a couple things. Can you see that? Yeah, you can. You guys can't. I'm going to do it once for you too. Don't worry. So, how can I do this so everybody can see? What am I supposed to do? Check out the arrows. What do they want me to like move here? Here, I can't even see. Okay, let's try again. Okay, what do they want me to move? What do they want me to do? Huh? Okay, so I'm going to move the coil kind of back and forth. See the little arrow? And I'm also going to move the magnet. See the arrow on the magnet? So I'm going to move the coil in the magnet. Let's see if folks back home knew that as well. Wait, do we have the right worksheet? I hope so. It's one called Electromagnetic Effects, like lab. Look down in it's in the stream, Inessa. Look down in there about 8 or 10 messages, and you'll find this sheet. So I did send it to you because I just looked. Okay. You're as exhausted as I am already? Maybe not. Okay, so I'm going to put this through here. And by golly, it's working, but not really all that exciting. Do I need it on that? Yeah, that works a little more. Okay, let's show it to you guys. So folks at home can see that. So when the magnet goes back and forth, I'm getting a little reading on my voltmeter. And actually, do I have a bigger voltmeter I can do this with? Let's do this one. Let's do this one. This voltmeter, if it's still working, is digital, and I can hold it up, and folks here, you might be able to see it as well as folks at home. That would be nice, huh? So now if I put the magnet through there, oh yeah, you're getting some pretty good readings. And I got this on 200 millivolts. Okay, so, and I'm getting lots and lots of millivolts when I do that. And then if I stop, it goes back to 0, if you can see that. I hope you can. Okay, so I start up. Okay. Let's do the opposite. I'm going to move the coil. Is it going to matter? No, probably not. Let's see. And by golly, yeah, that gets voltage too. And interestingly enough, you guys might be able to see it better than I. Half the time, I'll try and do it slower. Half the time the readings are what? Can you see that from here? Hard to see. There's a little something right there under AC. Half the time the readings are negative. So what is that probably telling everybody, folks at home too? It's negative because what's happening sometimes in the wires when I go back and forth with this coil? Why might it be negative like kind of half the time? What do you think, Aaron? First off, what am I causing to happen in the wire? If I could see inside the wire, what's happening? Exactly. So why would it be negative half the time? Stina, what does that sort of indicate? What about the electrons? No. Come on. They're moving electrons. Why would it be negative half the time? Check out what I'm doing. Are y'all? Yeah, well, they're not positive. The voltage is positive, right? The electrons are always negative. Yeah, when they move one way, the electrons move one way, then the voltage is positive. When I move the other way, the voltage is negative. Now, it takes a little while for the electronic to catch up. So, but I hope you see that about half the time, the reading is negative. I think it's when I pull towards the windows that it's negative. And then when I go towards the door, it's positive. Okay, but that's kind of the deal, isn't it? So really, for A, well, let's go ahead and fill this in, all right? You ready to write? So for A, everybody at home, the procedure was I kind of got it from Hannah and somebody else. First, I moved the then I moved the So Isabella? Okay, all right. So independently, one at a time, one at a time. And then observations, you can write first off, of course, what happened. Folks at home can write in there too, or you can just write it in your notes. You can look at the questions and put the answers right in your notes. If you didn't print a copy, it's okay. And for explanation, once you get that far, you can talk about what Ayala did, right? With electrons moving and the type of voltage you get. Electrons moving in the wire and what happens to the voltage. Folks at home, if you got a question too, please let me know. Please let me know. And while we're talking, tell you what, let's make this official for 8 periods so I don't get the same kind of dingy excuse here. Anna. Yeah, okay. So, yeah, just come on up and flash it to me, and then you go back and pitch it. And I'll put down hopefully your end for negative. Aslan, thank you. And Aaron, thank you. Hannah, thank you. All right, and Ethan, thank you. Thank you, Alicia. Isabella, thank you. This mask, it always takes me a moment to identify everybody. I know, thank you. All right, thank you. And Sina, thank you. And that is it. Life is good. Okay, thanks everybody for doing that. Sorry if I seem distracted. I'm doing like 10 things at once as I kind of have to. Okay, so I got questions here from my folks at home. What was the explanation again? Okay, what was the explanation again? Oh, these guys couldn't hear Ayala, so I'm going to say what Ayala said. Ayala, you said that when I move this back and forth, what's happening, Ayala, with the electrons in the wires? Yeah, when I go one way, the electrons, let's say they go this way. When I go the opposite way, they go the other way. So when they go back and forth, their movement is going positive voltage, negative voltage. And they go back and forth when the magnet goes back and forth, or alternatively, when the coil goes back and forth, depending what I'm moving, right? Okay. Whew. What do you call this phenomena? It's kind of like what that we did together on Monday. So what effect is it that we kind of did on Monday? Here's some markers.
Isn't it alternating current?
Yeah, it is. I agree, but you're getting really specific.
Oh,
It's just what more generally.
it's the,
Okay.
I forget, yeah. Oh, it's one of those, yeah.
It's the, see it?
Generator.
The generator effect. Yeah, but you're right. We're generating us on alternating current.
Okay.
So for folks at home, let me get so you can see the board now. So it is indeed the phenomena is the generator effect. We're generating electricity, and as Aslan pointed out, it's actually alternating current we're generating. But we'll come back to that. For now, yeah, we've got generating electricity. It's a generator effect. Ute. Let's go down to how you can increase the effect. There's 4 different answers. I gotta blow my nose. Folks at home can participate too. Give me one of the 4 answers. What's one way I can increase the effect, the amount of voltage? Okay? There's 4 different ways. Give me one way. What could I change about the situation? Ooh, lots of hands. I like it. Alicia, start us off. Oh, good. So what could I move faster? All right, let's do them one at a time. So one way is I could move the faster. Move magnet faster through coil. Move magnet faster through coil. Let's make sure my folks at home can see that. And I'll read it again in case they can't read my crappy writing. Move magnet faster through coil. Let's get a B. Ooh, I got one from Inessa. So here's a B from folks at home. Inessa says, get a stronger. What? Can you guess what she said there? A stronger, a stronger magnet. That would generate more voltage. Agreed. I got 2 more coming. Let's see if I got any others from folks here, okay. Let's get one from Isabella. Good. And more loops to coil. You might remember we did the Faraday's law, more loops, the more current. And that would work here too, you'd get more voltage. Oh man, erase the port, oh, that was me. Okay, some other people too. Last way. Last way. Yeah, that's why I kind of bugged Alicia to like separate it. So it's, there's actually two in there, Alicia. So, yeah, see, exactly. So move coil faster through magnet. Nice, nice, folks. Questions from folks at home or from folks here about station Uno? Because we got a lot to do. Whew. Okay, I'll get two ready while you're thinking. And actually, I can use the same setup for two. Except I need, the last one was called a horseshoe magnet, right? Because it looks like the horseshoe, you put them on the bottom of a horse's hoof a little bit. Okay, use your imagination. And this one's called a bar magnet. It's not a place you go, it's the shape of it, so it's in a bar, okay? Okay, let's see what we're supposed to do. What do he wants to do for that? What do you think, Kai? Yeah, good. We're spinning the magnet, and where? It's a little strange. Where are we spinning it? See that? Where are we spinning it? Where physically do they want us to spin it? Leave your eyes. Next to the coil. So we're going to spin this next to the coil. Okay, you ready, folks at home? We're going to do it for you and for the folks here. So here we go. And actually, I was not going to bug you. Can you hold this thing up?
Oh, sure.
I want you to hold it, and you know what? We're going to hold it right about there. And I'm going to make sure these guys at home can see it as well. And that, I think, is super. Can folks here see it? You can stand if you can't see it. Okay. Right now, it's 0.00, right? Okay, so, oh, but you're going to block folks too, huh? Okay, make sure you can see. Here we go. I know it's not a lot, but am I getting some numbers there? You guys got to tell me I can't see it. Am I getting a little voltage? Yeah. So even with spinning this thing out front, not even in the coil, and I'm still getting voltage. Thank you so much, Aslan. Okay, so let's talk about two, and that's the observation, all right? So observation, okay. Magnet spun next to the coil also made a little voltage, okay. Or you could say made some current flow, however you want to say it. So that's the observation for two. So everybody write that down. Folks at home, same thing. For two, so spinning the magnet next to a copper coil also made a little voltage. So I'm going to turn that off here for a second. What's the explanation? We must still be doing what? What must still be happening, even though it's not quite in the middle of the coil? I must still be doing what, Aaron?
You're turning in, so you're creating,
Yeah, like what does it have to do with the coil? So even though I'm not going inside the coil now, still what must be happening, Isabella? I'm causing the electrons in the wires to move, even though I'm not putting the magnet right through there. But clearly the electrons are still moving a little bit, aren't they? And so there's your explanation. Even this causes the electrons to move in the wire. Okay, what do you call this phenomena? Well, it's a little repetitious. What is it, Sina? It's again the generator effect, isn't it? So I'm still generating electricity. Even if I do it this way, I generate electricity, so it's the same effect. And last question, what forms of energy are converted? Okay, I gotta back up. See if you guys have had some energy in past years. I know Alicia had, because she had it, I think, with me. Alicia, I'm gonna ask you, when something's moving, do you remember what sort of energy in chemistry or physics they call that when something's moving? What type of energy is that? You don't remember? Oh, too bad. Okay, somebody else, can you pull it out, Aslan?
Kinetic energy?
Kinetic energy. So we're converting, I'm going to put this on the board too, folks at home. The last one, what sort of energy? So we're converting kinetic energy. Oh, not with the blue one, it's not nothing to converting kinetic energy to, well, I guess what do we say? Kinetic energy to
Electrical.
I guess electrical energy. I don't know what else to call it. In a sense, the electrical energy is also kinetic energy. It kind of means I'm moving electrons, but let's just call it electrical energy. That's okay. Yeah. So it's about converting one type of energy to another. That's station 2. Even though I'm not right in the coil. Okay, yes, yes. Happy? We okay? Questions at home or questions here? Okay, please let me know, because I know I'm trying to go fast, but I'd like to get at least station 3 done, maybe 4 if we're lucky. With the cart, incredible. This is the most full cart I've ever had in my life. And I blame it on Corona. I got to do everything over here in the blue building. Okay, but 3 is kind of a cool one. And some years I have students do it on their own, but I only got one setup, so, and I'm not allowed to even have you think around with it in this building. So here we go. Let's look at what this is. Folks at home, you're going to be able to take a look too at this thing. Yeah, let's do it. So I just come and move and stand wherever you can see this. And I'm going to show folks at home too. I got a voltmeter and I got this puppy right here. And you can guess the parts, folks at home and here, by seeing what happens. Okay, I'm going to turn this sucker. Oh, and immediately you can say, oh, well, that's my what? That's my coil. And it's turning. Well, can you guess what must be like here and here, if that's the case? Seen it? That must be your magnetic field, right? It must be a magnet, these 2 pieces of metal right there and there. So I'm going to do it a couple times and point to every direction. And I'm going to ask, and folks at home, I hope you saw some of that too. Now, I'm going to ask Alicia, because I can't see this thing for squat. Am I getting at least some little movement of the arrow? Probably not a lot, but a little bit.
Yeah.
Okay. Is it going only in one direction, or is it going up and down? Up and down. So if it's going up and down, Aslan, I'm still getting alternating current. So essentially in the loop, somehow I'm making the electrons do what? If it's alternating. Yeah, move, but how would they look if it's alternating? Yeah. So I know they're spinning this way, but they're also going right? So I'm making a move in the wire, and that is electricity, moving electrons in a wire. Oh, am I talking too fast? All right, let's go through some parts. Let's go ahead and write. So I'll hold up parts again, everybody, but let's finish up station 3. So, I'm gonna raise it, and right in the middle with you. So we're station 3. Station 3, folks at home. And the observation, station 3, all aboard. Observation. Well, what we want, when they turn, and that handle thing's called a crank. Not cranky. When we turn the crank, what sort of things happen? How can we describe it? When I turn, what happened, Ethan, when I turned the crank, what happened to this thing? The what did what?
You caused the coil spin, which make that electron move back and forth.
Good, good, almost complete. I caused the coil to spin in what?
And,
This thing must be
okay,
in a magnetic field. Turn crank, and coil spins in magnetic field. I'm going to abbreviate that to save time. Making, I'm going to say positive and negative voltage. Or we could say so electrons move in the wire, right? Or in the coil. That's pretty nice. Okay, yippee skippy. Explanation. Well, that kind of is the explanation. Observation and explanation. Or is there something I should add? What do you guys think? Okay, observation, explanation. No, like we kind of explained it too. I mean, that's what the effect is, isn't it? Okay, so what's this in a power plant called? A generator. Okay, is this a little repetitive? Yeah. A generator. Except they're much, much, much bigger. Okay, and we got them in Berlin, right? Everywhere you see a coal-burning power plant with those big chimneys and the big cooling tower, well, somewhere in there, as the steam's going through the steam turbine, it makes the generator spin, and that looks like this. So imagine this other end, instead of me cranking it, imagine that's connected to a steam generator. So remember the steam generator, we talked about that with your section, right? Mm-hmm. Steam generator spins really fast, and so this is going to spin really fast too. And make AC, alternating current. Beautiful. Are we done with this yet? No. Okay. Folks at home, let's see if you can get this. In English or German, what's this device on a bicycle called? It's like millionaires on it, okay? What's this device on a bicycle called? I'll give you the English and the German word, don't worry. Ethan. No, that's not the last question. No, it's before that. What's the device called on a bicycle?
What do you mean by that? I guess it's the pedal and the chain.
No, it's a separate device on a bike. You know what I'm talking about, Oscar?
Yeah, I think, like, I don't know what they're called.
Oh, it's got a name, and probably some of you at least have heard of it. The first letter is
Remember
D.
it fell off.
Is it the light?
Yeah, it's attached to make your light go. So what's attached to your light? It's the what? Starts with a D. It's a generator, but what's it called on a bicycle?
The wheel spinning like generator. That's all they call it.
It's easier than that. On a bike, I like that though. On a bike, it's called a dynamo.
That's funny.
Dynamo. In English, we call it a bike generator.
Okay. That's
Okay, so there's the German dynamo. That's something new, huh? That's why we're so bilingual here at the John F. Kennedy School, by God. Okay, the slip rings, we gotta talk about that. Let me wait and see if you got any questions so far, though, before we do the last thing. Okay, folks at home, I'm gonna show you the slip rings and then I'm gonna show the class here, okay? Folks at home, take a quick look. See this like white thing in that's the slip ring. So it's part of the axle that's connected to the coil. Okay, now let me come around and show everybody else this. I just pulled it apart. Frickin' A. Yeah. Forget it. No, that's not gonna work. Okay, so folks here, the white plastic thing is the slip ring. Let's see, we guess what it's for. Plastic. Going back and forth, huh? We're going to the white plastic thing. But it's kind of cool looking too, isn't it? But what's it for? That's going to be my question. So, see if you can come up with a theory. All theories are welcome. That white plastic thing. Okay, wait a minute. Throw out some ideas. Okay. Traction. No, it's not really going. It's just going in the air, so I don't need to have like traction like a tire. So I don't need that. Folks at home, you got to guess what this thing might be. Folks at home, you've been a little quiet. Ah, okay. Transmits powers, electrical signals, helps rotate the coil. Ooh, lots of good ideas from Alexandra. It has to do with power generation, Alexandra. So you're warm, so to speak, electrically warm. Do you remember this? On Monday, did we do the thing with the little? No way, really?
Oh.
Okay, we'll finish up on 8th period today. So hold that thought. We'll talk about the slip rings, 8th period. Man,
We have the best class of the day now.
I starting to feel like I'm running a marathon. Holy moly. Okay, well, we got 2 stations done.
Ethan, what do you have?
Holy. Thanks, folks at home. We'll see you 8th period. Bye. Thanks for coming.
I know, it's not that,